So we've said, all right, let me just write down over here our vectors. You said force, right? You said velocity. Yes, it has a value, yeah. So a magnitude.
That doesn't have a direction, right?
Well, let's think about it. What is an example of like an acceleration that's kind of like in everyday life?
Like a car speed.
So if you press the brake, which way is your acceleration going?
Backwards.
So does the acceleration have a direction?
Yes.
Exactly. So yes, acceleration. And then one more.
Okay.
You're doing really good though.
I would say speed, but that's kind of the same thing.
Well, speed is typically considered a scalar quantity, right? Because what does speed typically tell you?
How fast something goes.
Exactly. So it just gives you the magnitude. So a vector has to give you magnitude.
And direction.
Exactly. So we're driving, right? You're going, when you're driving, you're covering a certain distance, right? Over a certain amount of time, right? So that's your velocity. So velocity is just the distance you've gone over a certain amount of time.
Okay.
So I guess the other vector I was trying to get you to key into was just distance.
Oh.
Yeah. And can you tell me why distance would be another one of your vectors?
Well, of course it has a direction. I guess it has a value.
Yeah, so you can say that, like if I throw this marker, right? It would have gone a certain distance, right? So like I throw this marker 10 meters.
That's the value.
Exactly, so that's the value. Alrighty, so I'm just gonna give you one practice problem to see if you understand it. So if I say Jane, she traveled 10 meters north, let's say 5 meters east, so 6 meters southeast, and then she returned home. So what would her displacement be?
21 meters southwest.
Let's see, so you said 20, so she goes up 10 north, right? And then she goes 5 meters east. So what's the resultant vector just from that small movement? Do you remember what resultant vectors are? Okay, so we need to go over that. All right, so let's put this problem to the side for a little bit.
Okay.
And let's go over resultant vectors. Okay, so I'm trying to think of an easier way to explain this. All right, let's use projectile motion as an example, right? So you're throwing something. What can you tell me about projectile motion? Yeah, it's going to go up and come back down. So what makes the ball go up if you throw a ball?
Force.
Yes. So we have force, if we're throwing a ball, you have force going up, right? And which direction, which axis is that in? Exactly. And then if we've thrown it and it's going this way, what does that mean too? Exactly. So we have force in that direction too. So as you can see, when you have something, like, so we have our ball, right? And we're saying that we've thrown it and it has like an angle here and it's making this vector. So that tells us that we have an x component and a y component. So vectors always have an x component and a y component.
Okay.
So let's go back. Let's see if you understand it a little better. All right, so this is what, this thing in the middle of the vectors is called a resultant.
Okay.
So this is the resultant. So this is kind of, if this is made if you add these two vectors together.
Okay.
You guys have covered adding vectors, right?
Yeah.
Did you understand it?
Yeah.
All right, let's just try to add a couple of vectors just to make sure.